Now we discuss about collision theory of reaction rates. Actually, this theory explains, the collision theory explains how a reaction proceeds. After all, a chemical reaction is nothing other than the reactants are getting converted into products. So this theory explains how a reaction, especially a gaseous reaction, is proceeding. So you consider two gaseous reactant, two or more, whatever the number may be, they are reacting to get the product. Remember, a chemical reaction is nothing other than breaking of existing bonds, that is in reactants, in then formation of new bonds in products. So breaking of bonds and formation of bonds. So according to the collision theory, how this happens, the breaking of bonds and the formation of bonds happens. For the breakage of the bond, it requires the collision of the reactant molecule. Collision theory is best to explain the gaseous reaction. So what is happening is the reactant molecules are colliding with each other. So while they are colliding with each other, what happens is the bonds will break. The bonds are just like a spring. So whenever they are reacting with each other, the energy will be transferred from one molecule to the other molecule, so that the molecules are in a vibrating mode. They are just like a spring, the bonds, they are in a vibrating mode. So the vibration speed, the extent of vibration will increase. Ultimately, the bond will break. So this is an overall view of how the reaction is proceeding. So we'll come to the collision theory. Now we'll discuss the postulates of the collision theory. And so before that, once again I remind you, a gaseous reaction is happening in this way. Not only a gaseous reaction, all the reactions. Since the collision theory is especially to a gaseous reaction, we are focusing on that. So the reactant molecules are colliding with each other, so that the existing bonds will break and new bonds will be formed. Now we'll come to the points, that is the postulates of collision theory. So the first one, according to a collision theory, the reactant molecule must collide with each other. But all the collision does not lead to the product. Molecules must collide, but all the collision does not lead to the products. Only those collisions in which the molecule possesses a minimum energy called a threshold energy. You may be heard about the term threshold energy. The minimum energy required to participate in a chemical reaction is known as threshold energy. So the molecules must collide with the minimum energy called a threshold energy can get converted into the product. So first we said all the reactant molecules must collide, but all the molecule may not have that enough energy called threshold energy. So only those collisions in which the molecule possesses minimum energy called a threshold energy can get converted into product. So let us consider a reaction. The reaction is here 2HI. Two molecules of HI get converted into product called H2 and I2. So let us say this is the way how they are reacting. Here you have one molecule of HI, there is another molecule of HI. So before getting products, what happens is they will be converted into an intermediate compound. And what is that intermediate compound? You can see here the thick lines indicates the existing bonds are broken. They are partially broken. These are the existing bonds which are partially broken, while the dots indicates the newly formed bonds. They are partially formed. So this is the intermediate stage. And finally what happens is the existing bonds completely breaks and new bonds completely forms. So this completely breaks and this forms H2 and this forms I2. So you got the product. Clear? Now we'll consider the same reaction again you have one mole of HI, another mole of HI. Let us say they are colliding, and we assume that they have enough energy called threshold energy. And all the conditions are satisfied now. They are colliding with each other and they possess what is so called threshold energy. Now what happened? These are the existing bonds which are partially broken. These are the newly formed bonds which are partially formed, and the existing bonds completely breaks. Now what happened? Look, actually the final result is 2 mole of HI itself. So you started with the 2 mole of HI and you ended with the 2 mole of HI, which means there is no reaction. What happened? The molecules collided as per collision theory and they possess enough energy called threshold energy, but still there is no products. And what's the reason for that? The reason is they are not properly oriented. So there's another condition. The molecule must be properly oriented. Here you can see they are properly oriented. So that also must be a criterion. So these are the criterion. The molecules must collide with each other and they must possess certain energy called threshold energy, and during the collision they become an intermediate state, sometimes called activated complex also. So they get activated. Now only those collision in which molecules are properly oriented must lead to the product. Such collisions are called effective collisions. So what do you mean by the term effective collisions? Collision of molecules with enough energy called threshold energy, and molecules are properly oriented, and such collisions are called effective collisions. Now we can say, according to collision theory, the rate is directly proportional to number of effective collisions per unit volume per second. So that is what is called the rate. Of course, as the number of effective collisions increases, rate of the reaction also increases. Now here we introduce a term called Z. Z is defined as the total number of molecular collisions per decimeter cube, that is per unit volume per second, which is also called collision frequency. So what is that? You have a sample of gas. There are a large number of molecules. All the molecules are colliding, and we are considering the total number of molecules colliding in that volume per second. That is called the collision frequency. But remember, even if all the molecules are colliding, only those molecules which are activated or which are having threshold energy will lead to the product. Clear? So in that sample of gas where the molecules are colliding, we can say only a fraction of the total number of molecules are having that threshold energy, and that fraction of molecule having get activated or having threshold energy is indicated by a term called exponential of minus EA by RT, called e raised to minus EA by RT. This is obtained from an expression called Maxwell-Boltzmann curve. Maxwell-Boltzmann curve will give you this kind of expression. So this is a total number of molecules which are colliding, and this is a fraction of total number of molecules which are having enough energy. So if you multiply between these two, Z into e raised to minus EA by RT, this will give you the fraction of molecules which are colliding per unit volume per second. Clear? Now we can say that is the number of effective collisions per unit volume per second. This term will give you that term. That is number of effective collisions per unit volume per second. Now in general we can say rate is equal to K into A, concentration of A. If concentration of A is equal to unit T, then rate equal to K. So instead of this rate we can substitute here as K by applying these conditions. So now the expression become K equal to Z into e raised to minus Ea by RT. Now this is the form of the collision theory where K is Rate constant. Now we can introduce another term here, P, called as steric factor or probability factor, which is nothing other than to express the orientation, proper orientation of the molecules. So we can say K equal to P into Z into exponential of minus Ea by RT. So this explains the reaction according to collision theory, or this is a mathematical expression of a rate, how the rate is proceeding according to this theory. K equal to P into Z into exponential of minus Ea by RT. K is rate constant, P is steric factor or probability factor, Z is collision frequency, Ea is activation energy, R is universal gas constant, and T is temperature in Kelvin. Thank you.